Okay, so here's another example, number 74. We're to graph q of x equals 4 divided by x squared minus 16. One thing we might want to do is we might want to write that factored form 4 over, there's a difference of 2 squares, x squared minus 16, factors into x plus 4 times x minus 4. But we still don't have any factors that reduce. Okay, so we're going to go through our steps as prescribed. First of all, y-intercepts. No, not intercepts, not plural, intercept. 1 at most. Okay, the y-intercepts are going to occur at x values of 0. So we're going to evaluate q at 0. I'm going to do that into this form right here. Fewer things to put in. So I've got 4 over 0 squared minus 16. So 4 over a negative 16 reduces to a negative 1/4. True? Okay. So 0 and then a negative 1/4. There's my y-intercept. Okay. 2 x-intercepts are going to occur when this fraction takes on a value of 0. Well, for this particular example, where our numerator of 4 is going to take on a value of 0, that's not going to happen. So we are going to have no x-intercepts. This thing is not going to cross our x-axis anywhere. Okay? Now, for the third thing, let's look at equations of vertical asymptotes. Those are going to occur when the denominator is equal to 0 for real values where the denominator is equal to 0, where this x plus 4 times x minus 4, if I want to work that in factored form, is equal to 0. So where x plus 4 equals 0 and x minus 4 equals 0, at negative 4 and at positive 4, we're going to see some vertical asymptotes. So let's go dash those in. At positive 4, also at negative 4, we're going to dash these vertical asymptotes in. Okay? Step 4, remember, is the horizontal or slant asymptotes. I've been abbreviating that the whole day. I might as well keep on. Horizontal or slant asymptotes. Now that's where we compare the degree of the numerator, which it is 0, versus the degree of the denominator is an x squared, so it is 2. When the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at y equals 0. Okay, it's at y equals 0 anytime the top is less than the bottom. Okay, now we want to see if our function q of x is ever going to cross the horizontal asymptote. Okay? Well, if our function of 4 over x squared minus 16 is ever equal to 0, that thing will cross the horizontal asymptote at y equals 0. And I don't know why I've been waiting around. I haven't dashed in that horizontal asymptote at y equals 0. Let me do that. There we go. Y equals 0. All right, so back over here, number 5, seeing if this thing is going to cross the horizontal asymptote. Again, if you want to clear out the fraction by multiplying both sides by x squared minus 16. Okay, Those factors would reduce over here, leaving you with 4. And on the right-hand side, 0 times the quantity x squared minus 16 is just 0. 4 is not equal to 0 ever. So, no, it's not going to cross the horizontal asymptote. Okay? Now, the sixth thing we might want to do is we might want to think about symmetry. Okay? For our function q of x, I want you to realize that we do have all even exponents with the 4 over x squared minus 16 because the 4 is understood to be 4 times x to the even exponent of 0. We have an even exponent of 2 right here. And the 16 is understood to be 16 times x to the 0. We have all even exponents. This thing would pass the test for an even function. So that means we're going to see symmetry about this y-axis right here. Okay? All right. You may or may not want to do that, but we do have to do some more points. We have to figure some more points. We're going to pick out some good x values, and we're going to figure their corresponding y values, or q of x values. Okay? Now, I'm pretty sure I know what happens since this thing does not cross the horizontal asymptote, but it has to go through this point and is... excuse me. Ooh, and is symmetric about the y-axis. I'm pretty sure this thing is just going to do this right here, and then same thing over here on this side, this right here. Okay? That doesn't look great. It's supposed to be symmetric. I think I can do a little bit better. Okay? But whatever, that's close enough. Okay? Now the question is, how does this thing behave otherwise? Here, I'm going to sketch in the possibilities in purple. Either here, it's up here along this way somehow, or it's down here, one or the other. Okay? And then over here on this other side of the line, x equals 4, it's either going to be up here or it's going to be down here. It can't be both because then it would fail the vertical line test, right? So that's what we're going to look at next. We're going to see what happens for x values. Okay, what happens for y for these x values that are like less than a negative 4. So maybe I want to see what happens when x is a negative 5. Okay? And then over here, I'm also going to need to see, is it up or is it down, like I have drawn there? Okay, and we're going to find that out by saying maybe let x be equal to positive 5. Sound good? All right. So now I'm going to come along here and I'm going to calculate q at negative 5. Okay? That is, going back to my equation, 4 over negative 5 squared minus 16. So that's going to be 4 over 25 minus 16 is 9. So 4/9. Here's what I found from that. At negative 5, we're up here at 4/9, which is almost a half. Okay? And so what I know now is that my function is up here. Okay? It doesn't cross y equals 0. Okay? And since this thing is symmetric about the y-axis, I also know if you put in a positive 5 here, instead of a negative 5, you're still going to be having 25 minus 16 in your denominator. So it is also 4/9, right? And so it's going to go like this over here. Sound good? Now, you can then, okay, I'm at least going to just label this q of x, and you can write the whole equation if you want. If you have a handy graphing utility, you might want to put that on there just to check. But do not graph it until you've done all this legwork. And I'll tell you why here in just a little bit.